All right, so we're here with CJ. He's going to tell us a little bit about their AI software that works on top of multiple robots, right? It's kind of robot agnostic.
Exactly. So I wouldn't call it robot agnostic. We work with Universal Robots, with Fanuc, and also with KUKA as well. And basically, we are an AI system that helps these robots to overcome variance. So the system is called MIRAI, and basically what it's doing is, like with any type of like robotic application, you want it to be as repeatable as possible. Everything fixtured down, but in a lot of applications, that's just not the case. There's going to be things that aren't going to be perfectly fixtured. They move around in the time that you maybe take a photo to when it's going. So our system is designed to help these robots to think a little bit more for themselves and do a little bit more like a human does and be able to place these parts properly.
Are there a few applications for which you've seen a lot of success for your software?
So one is cable plugging has been really big for us, where these cables are floating out in free space. They don't know the exact position of these wires, these connectors. So being able to find that cable, being able to grab it and plug it in. The other big ones that we've been doing is screw driving, where like a screwdriver or riveter, the whole position isn't completely fixtured, or it's not in the exact same spot every time. There's variations in terms of the part position or the quality of the part. So we're able to like have a hole here, and we're able to place a like an end effector or a screwdriver from over here, and then place that into that correct position.
And since it's AI, how much ability is there for manual adjustments to the program? Let's say you develop some recipe and you like it 99%, but there's this one part where you just want to go in and manually adjust something. Is that possible?
It's not. It's possible. What really comes down to it is like there isn't really like programming that's done of it. It's teaching all that's coming from like from your input. So we're using what's called imitation learning. So everything that it's doing here, everything that we're teaching it, is coming from like what we have shown it, like how to do it. So if it's doing something that it's not supposed to, it's because you inputted something that it wasn't supposed to do. So in order to fix that, you can basically just remove the parts that you like weren't supposed to show it, and then for this one it's able to then you're able to say like, okay, like instead of doing this, we want to actually show it doing this. So you're able to kind of just work around the inputs that you're able to give it.
Terrific. Anything else we should know about this?
Yeah, we're able to work like all across the country. So we work with integrators just like you guys. So if there is any sort of like application, like we've talked about like just two of them, like we've probably done 25, 30 different types of applications, and we're always finding different ones. So if there's anything that comes up where there's just some sort of like weird piece of variance that you're not able to like figure out how to work with, just talk with us and see if there's something that we can help with.
Perfect. Appreciate it, CJ. Thank you.